Okay, so here we go, the final video. This will be just kind of a recap of everything that we've gone over so far, and then just going into the last and final questioning about the car. So, just for a review, I'm just going to go over some of the parts of the car, just so you can remember everything. But obviously, we've got a cardboard box as the base and the main frame of the car. We've got the CDs as the wheels. And then we've got the double axles, they're dowel rods, you know, quarter centimeter width. And then we've got the fishing line for the string. Yeah, you can see that. Maybe you can see the shadow, but the string for the braking system, the axles with the cotter keys and the washers on the side, and yeah, that's my good humble car. um, it's been really awesome seeing this car work and go into action. I've learned a ton about the physics, and I'm really proud of this car. But um, I think it was really interesting learning how the braking system and trying to manufacture something like this while working with the same principles that we work and see with in class all the time, like friction and momentum and kinetic potential energy even. And so it's just really, it was really fun getting to learn all those things in kind of a hands-on experience. But just so we can go over some of the couple of things. Uh, One thing that I think I learned about the braking system is that it's very important to take into account for friction and the mass of the car and how fast it goes down the ramp. Because with all of this in mind, the braking system is created so that it can make a force strong enough to hold back the car when it's going forward. And so if it's going too fast, then it's what's going to happen is it goes and it keeps sliding forward, or the braking system will be powerful enough to stop it, but it will also roll back at the same time. So you don't want any of those happening, because if that happens, then you're not going to be as accurate as you could be, and you can't adjust it as easily. Okay. Another thing that we had to deal with friction in the car, I think I've already showed you, but the cotter keys and the washers. Learning through that process was pretty simple. When designing the car, we had to think about what would make the car run the smoothest, and the axles would be, well intended and most useful. So I chose to put the metal on metal so that there would be less friction. And obviously, it's a cardboard box. There would have been a lot of friction had I not gone inside and drilled out some of the holes and then made. Because the metal on metal obviously reduces a lot of friction. There's still a little bit, but not as near as much, and that helps the process out a lot because it's not something here that's pulling it back. We can reduce the amount of work that we have to work on the car and work exactly on like the braking system, or if something is bent or out of shape, or one of the CDs are broken or something like that. So it's kind of interesting how we figure that out. One thing that I really thought was interesting was potential and kinetic energy and the whole energy process. Normally, you don't think about energy in that sort of way when you're thinking about like a car or something. Normally, you think energy like, oh, electricity. Well, even right then, you had to think about how great the energy was going to be at this mass of a car. I mean, it's not terribly heavy, but still, it's a little heftier than some cars, I would think. And so, taking that into effect, you had to worry about, you had to worry and manage, of course, how you wanted to, how you would see the connections between those two, because going down the ramp is just as important as going and hitting your breaking point. Because if you go off too fast or too slow, then that can affect every outcome of the race later on. And so it's really important to watch out for that. One of the things that I kind of found interesting was that Newton's three laws, and obviously we don't have too much time to go over this, but over inertia, over the forces, and stuff like that. It was pretty interesting. Like, normally you read about Newton's laws and how they affect, but when you had to think about making this project, you really had to examine the forces that were going on and which ones, if this one force wasn't the problem, like if the friction wasn't the problem, then maybe it was the braking system that was loose, or you had to examine all the little details about the car before you could go ahead and say, okay, this was wrong and this is right and this could be better, because you could change and remake the whole car and still have it do just as well or just as poorly as it did before. So you just have to micromanage all those little things. I think the hardest part of the project, honestly, in my opinion, is probably just the whole design of the car itself. Because in reality, we're not mechanics. It's kind of hard to just come up with ideas out of the thought of your head. Now, this project was extremely fun and easy to do, and I enjoyed making it. But coming up and sitting down and saying, okay, what are the problems that we've seen or can imply will happen, and then trying to base a design off of an implication. It kind of was like a leap of faith, and so figuring out and making the little adjustments and making it work really turned out for the better. And so yeah, so that was probably the hardest point of the project, was just the whole inventive part of it, because putting it on paper made it a lot easier in the later runs, so that you could make smaller changes, not big, like gigantic changes. And then also, speaking of changes, if I had to change anything about this car, I think I would change out the CDs, because CDs, if you can't tell, they crack easily down the middle if you don't bend right. And with the way that my car is hooked up on these dowel rods, what you had to do is you had to take some sandpaper and screw out the inside of it to make it squeeze onto the dowel rod, and so that would make the wheels bend and break and not as reliable as they could have been. Also, one thing that I think would have been cool to add is, I'm not quite sure of the name, but something where you put a row of gears or something, and you put an attached a piece of plastic that rolls with the axle, and as it rolls, it will go forward in one direction but stop in the other and get jammed in one of the gear heads. And so I think that would be cool, because not only would it be would the braking system itself stop the car while it's going forward, but instead of it going backwards while it stops, that would be really helpful, because you want the car to be as reliable as possible. And so if it goes forward a little bit, then you can adjust to that, but at least you can say, alright, at least it's not rolling backwards. Alright, so we've been through so many things together with this car, and I'm really proud of it. Thanks for just watching and helping out, and I hope you've enjoyed seeing all these cars. Thank you.